Later on in this chapter, some of the things we do that involve factoring will also involve square roots. So let's get some practice with square roots so that we can get comfortable with them. Square roots use radicals. A radical looks like this. You'll see this sort of angular shape and it covers whatever your root is. And if you don't see a little symbol here, if you don't see a little number there, you assume that the root is 2. And all other roots are indices on top of the radical sign. If you look down here, this is a third root because we have a 3 here. This is a square root. There would normally be no symbol there, but we have a 2 there. If this was a 5th root, you'd see a little 5 there. If this was a 12th root, you'd see a little 12 there, and so forth. Radicals are nice because they undo exponents. If we have an exponent in an equation, we can use radicals to get rid of it. So for instance, this is the third root. We also call it the cube root of 4 to the third. That simplifies to just 4. The square root of 25, you can write that as the square root of 5 squared. Again, we have this match between exponent and index, and for that reason, we can simplify this and it just equals 5. 6 doesn't have a nice square root. You could do it on your calculator if you want to, but it doesn't have a nice square root. What you can do, that will turn out to help though, is you can write it as the square root of 2 times the square root of 3. And we'll actually be able to use that idea of splitting when we simplify. And as it turns out, even though some radicals won't be nice, like 6 won't, we will have the ability to make them simpler. And we do that using prime factorization. You may want to watch the video on prime factorization if you haven't seen it in a while. We use prime factorization to eliminate radicals where we can. And then when we finish, we multiply numbers that are under matching radicals. That sounds complicated. Let's take a look at an example of this in action. Example 1 gives us the square root of 343. If you prime factorize 343, that turns out to be exactly 7 cubed. And we can write that as the square root of 7 squared times 7 to the first. You don't need an exponent for a 1 there. Up here, we broke 6 down into 2 roots. We can do the same thing with example 1, and I can write this as the square root of 7 squared. I put a little 2 there so you'd remember it's the square root. And then we have the square root of 7. And technically you don't need a 2 there, but you could write one if you wanted to. The square root of 7 squared is 7, and so we can write this as 7 times the square root of 7. Example 2 is similar. For example 2, if we prime factorize example 2, we get the cube root of 2 to the 4th times 3 squared. Again, I'll split this up. And again, just like I wanted to get 2 of these away so I could simplify, I want to get 3 of these away so I can simplify that. I can't do anything with this little 2 up there, so I won't bother. I will just write this as the cube root of 2 cubed. And then, much like when we were factoring, I'm just going to put the remnants in the other root. We still have a single 2 left over, and we also have 3 squared. Well, the cube root of 2 cubed is simply 2. So we have 2 times the cube root of 2 times 3 squared. That works out to 18. So just remember to look for powers that match what your index is, and then you'll be all set.